Hello, welcome to another trigger tutorial. This one is quite an exciting one as it is about the creation of a map using triggers alone. You are used to scenarios where you create the scenario handcrafted with painting cliffs, forest and terrain. You may have come across random maps where some complex code and scripts generates the maps. Both of these generate maps before you play and don't provide a way to change the map during the game. However, there is now a third way to create maps, and that is with the use of trigger code, or in this trigger pack it's just going to be triggers alone. Some of my existing maps like Gladiator Worlds makes heavy use of this in script form, but for this tutorial we're going to look at creating a map in the scenario editor with triggers and on the fly. So this map will almost be like a random map, except it won't be, of course, it'll be in scenario form. Let's have a quick look at some basics before we get right in. First of all, we want to insert our trigger loader as per usual. So let's just put that in. Trigger loader. And let's put that. Oops. There we go. Initialize trigger loader. And let's have a look at some basic effects. But before we do that, let's just make sure we can see the map when we play, because otherwise it's going to be annoying that we can't see it every time. So let's just do that. One interesting way of doing that is you can just toggle the visibility of player 0. So if we give ourselves line of sight of player 0, that gives us full proper line of sight of the map, making everything revealed to us. Now let's go through a basic effect. So if we go and have a look, the new section is these world effects, and these world effects have a lot of different things. There are some 4 loops over tiles, which allows you to do operations depending on the tile or vertex. We've got some location getting, replacing, setting heights, setting terrain, some smoothing. We've got some terrain types, and we've got some obstruction updating. I'll just give a very quick example of something basic. So let's just say terrain circle, set terrain circle, and let's just put some snow. Let's do north snow 1 in an area like so. And this should give us a revealed map with the snow on there in a circle, which we do. One thing to note is with the effects I've added, the terrain won't update the obstructions until you explicitly tell it to do so. So a quick example with that is if I drop down some and if we paint it with cliff instead, just check how it is going to be under here. It should be north cliff. There we go, north cliff 1. The anibites will be able to move freely on the terrain. The reason for the obstructions not applying by default is for performance reasons of the painting. If you have every single paint command updating the obstructions of the terrain, it will drastically slow down. So instead, when using my stuff, you need the explicit obstructions. So I'll just give you an example of that. So after our painting of terrain, we will paint obstructions. And if I launch now with the obstructions, you'll see that now the cliff is actually acting as cliff. So that's some very basics. Now, let's have a look at creating a map. And we want to, for this example, we're going to generate something quite interesting using a technique I've used a few times on some maps, which people may not necessarily be aware of. We're going to create like a maze-like terrain, and this maze terrain is going to have paths, and there's going to be some forest, we're going to have some cliff, and we're going to have some water pools, and we're going to have these paths weave in and out of these water between these different obstructions. Now, what we're going to do overall is the following. We're going to generate some random hills of different heights on there around the map. From these hills, we're going to use the steepness of the sides of the hill in order to create our paths. The hills themselves are different heights, so we're going to use for determining whether the areas are going to be forest, water, or cliff. Once these sort of hills are sort of generated, and we've generated our forest, cliff, and water areas, we will then sort of turn them into the proper areas with the map. It's a bit of a strange technique, but hopefully as we go along and work through this, it will hopefully make a little bit more sense. One thing to note is if you go into my API, you may notice that there is a very lack of water manipulation. In fact, there's only one command, which is to paint the entire map with water. This is because the general API for painting water is a little bit weak and messy. And generally what I have found when making maps is it's a lot easier to paint the entire map with water, create your map, and then raise the entire thing so that the water only covers the low-lying areas left over, than trying to figure out how to get the water to paint accurately, because as I say, it just gets very finicky. There's also quite a lot of bugs at the moment with the water painting. The rectangular command at the moment has an off by 1 error, and the last time I was checking, the paint water in a circle didn't even work at all. So we will be using this technique instead. So let's begin. So first of all, we're going to want to paint ourselves the water on the map and initialize the terrain ready for the rest of the map. In order to make things a little easier and keep things broken down, we're going to make use of events to break up the code into separate triggers, and then we can handle each problem one area at a time. And it also prevents the screen from filling up with too many triggers at once. So let's begin with that. So if we're going to create a new trigger, this is going to be the trigger that's going to run all the terrain, all the generation. So let's just call this something like generate map. And what this trigger will do is it will call through to it'll trigger all our events, and our events, when they are called, will perform their tasks, and those events together will generate the entire map. So let's begin by doing a water paint. So let's just go ahead and do that. So we've got our event effects, and we're going to want to create our first handler. So this one's going to be, let's call this water handler. Remember that events need to be there before you can fire them, so generally if you're doing a handler, I recommend using the run immediately to ensure that it is existing beforehand. Right, so in here we're going to need to declare our event handler. So let's do that. Event handler start, and we're handling the water event, and with that we're going to paint the entire map with water. There is no way to choose what the height of the water is. I think it's always about height of 3, regardless of what you try and do and what the terrain is. again, there's just a lot of problems at the moment with water painting, so this is why we're going down this route. So let's have a look at that. So we can choose ourselves a river, lake, or ocean. Let's go for a river, and let's go for the Greek river. Once we've got the event handler sorted, we are going to want to end it. So let's do yeah, and handler end, and then we want to fire the event. So events, and it's an empty event, so we can just fire it. And we want to fire that it is a water event. So let's just see if our initial water works. Okay, good start. We have our water. So next thing to do is let's have a look at generating our hills that we're going to use. Now the water is going to get in the way a little bit of our visibility. So for now, let's I'm going to deactivate the water on our map generation, but we can always put it back later on. That's one of the nice things with using the events. It's easy to turn things on or off. So let's just rename what we're going to do, because it's going to be our next event handler, and we're going to call this let's just call this the hills. And let's create a new trigger, make sure it's run immediately, and let's call this hills handler. So this is what we're going to use to generate our initial hills. And with that, we're going to want to generate the hills way below the water. And you might go, okay, why are we doing this below the water and not just doing it immediately where they're above and below? So one thing to note is that when you raise the land above the water, you lose the water, and we don't want that. We don't want the water getting interfered with. So the safest thing to do is to do everything under the water, where the water would be, and then raise it up at the end. So the land would never go above the water and then below the water. We've got a trigger that can raise the entire land globally, which is what we can use towards the end to have things appear a little bit better. But we'll worry about that when we get there. But main thing is that we need the height to be low. So let's so we've got our hills handler. We want to do an events handler. So let's sort that out. So events handler start, and we've called it hills. So the basic gist is, let's set ourselves a base height, and then we're going to create hills in and around that height. So let's make sure we are well below the water with no risk of interference. So let's just use the set height. And the world set height will just move the entire land to be at a given height. So we'll set that to -20. We also could initialize the terrain to something. Now at the moment it's just whatever the water is, but it's going to be helpful if we know what the terrain's going to be when we do everything else. So let's also initialize what our terrain is going to be. And the map, as I say, is going to have some paths. We're going to have some hills, some hills, forests, and water. And that's for now. We're going to say that the forest is going to be at the sort of base level, with the paths sort of going in between. So probably the easy thing to do, which will come back to us later on, is probably just make the entire map forest terrain for now. So let's just have a look at doing that. So if we do set terrain, and we're going to set the terrain to be a forest. Let's go for just simple Greek, and we'll say Greek forest grass. Seems reasonable. And let's just put our event handler end in, so that we can just check that we are happy. Whoops. Handler end. So our generation will now just fire the hills to start with, so let's just check that we get that. We might not see much change, other than the water might, the terrain might look wet, as the height is different. But yeah, we've got our terrain all ready and good. So now our next step is to generate our hills. So let's have a look at doing that. So we want to create lots of locations on the map and change the height to different heights. We're going to say that some of the heights, as I say, are going to represent the cliff top mountain tops. We're going to have some that represent the forest, and we're going to have some that represents the water. For this example, let's have it so there's a little bit more forest than the other two. So we want the height that's going to the forest is going to be able to be a little bit more common. So what we can do is define ourselves some heights that are going to represent our different things. One way we can do that is to make use of the parameters. So we're going to create a parameters. Parameters. And we're going to create ourselves one. And this is going to be our sort of terrain heights that we're going to use. Now, one simple way is if you wanted to pick something that's slightly more often than others, is if you're picking from like a list, you just have that item in more often than others. But yeah, let's just define the heights that we're going to use for our things. So if I use the parameters and add non-empty ints, actually no, floats is probably more correct. As I say, we're going to it's representing our terrain heights. In fact, let's just make it plural. It makes a bit more sense. So let's put those in. So we'll define our water one. So let's so our current height is -20. Let's do that's going to typically be something a little bit lower. So let's do -25. Then let's have a forest of 20. We'll have another one of 20. Oops, make these decimals. I don't think it matters, but we'll make decimals anyway. And let's then have a cliff one. Oops, these should be -20, not 20. And then we'll do -15.0. So there's one chance of generating a water, two chances of generating a forest and area, and one chance of generating ourselves the cliff terrain. Next, now that we've created our parameters, we're going to want to for loop over. So we do it lots of times. So let's have a look at that. So let's do for loop, which is going to be where we're going to create our hills. So we want just a normal for loop will do. Here we basically can set how many different hills we want to create. Let's just say 100 will be good enough for now. Then we're going to want to pick random locations on the map. If we look at our map size, it's 200 by 200. So that's the values that we're going to need to generate between. So let's generate some variables that can hold the random location. So we can declare a random float. Let's just call this posx, starting at 0, going to 200. And we'll duplicate that and do a pos z. So this will represent two random locations on the map. We're going to want to pull a height out of our parameters. So let's have a look at doing that. That we're going to generate our hills at. So we can do get float declared. And our parameters, we call that terrain height, so let's just copy that so we don't make any typos. And then the index, we need to determine which one we're picking. We'll come back to a second and we'll declare that as, I don't know, height. So yes, we need to pick a random number. So let's sort that out. So if we just declare a new variable, random, and we want to do a random int. Let's just move that down. And we created 4 of them. You can just get the count on number of parameters and store it in a variable and then randomize at that, but we know there's 4 of them, so we'll go for that. So we're going to want to pick a random value. Let's call this height index, because that's going to be the index of the height parameters that we're going to use, and it always starts at 0, and we're going to go to 3. If we look back here, index 0 has -25, 1, 2, and 3. So those are going to be the values we want to pick between for our height index. So we're going to grab random height with our height index, and we're going to store that in a variable called height. Then we're going to want to create some hills. So let's paint some elevation at a random height. So if we go to the world, we should have a set height circle, which is what we're going to want. And we want it to be the height that we have declared. Oops, we need the free text version because we're going to use a custom location. There we go. We don't want it to be relative because we want it to be just those absolute values we set. And the location, well, we've got our variables pos x and pos z. So let's put those in pos x and pos z. We'll do a fixed radius. We might look at randomizing that, but for now we'll just use a fixed radius of painting that hill. We're going to need to end our for loop, so let's end it, and then we're going to need to shift our handler down. There we go. So just quickly go through, make sure we've got it okay. So we've got our hills handler. We set some height. Ooh, we actually set it to 20. I meant to set it to -20 earlier. We're going to set it to some forest. We're going to declare our terrain heights. We're going to add some values in. We're going to for loop. This is going to be how we're going to generate multiple hills. And there's going to be 100 of them. We're going to grab a location, X location, randomly between 0 and 200, and our Z location. We're going to choose a random height with the right height index, and we're going to use that index to get an actual height using our declared parameters. We're then going to paint a random circle height at a random location that we have determined with a radius of 20, and then we're going to end the loop, and then we're going to end the handler. Let's give that a go and see if we got this right. Okay, so now it is underwater. Now you can see that the terrain is wet. Don't worry about that. That is a ongoing bug with the game currently, with the terrain being wet. You might see at the map edges it's a little strange. That's actually not like that. It's to do with the fact that it's revealed while on the site. There is a bug where the map edges don't work properly. But if I put a cheat in, you'll see that the terrain actually is down. And it is an issue with the way that the map sort of reveals itself. There are some workarounds to making this work properly without having the map set revealed, which I may or may not cover in this video. We'll see how we get on. But you can see that we've got some hills, but they look quite ugly at the moment because they just sharply go. So let's throw in a bit of smoothing to just make the hills appear just that little bit more natural. So if we go back to our hills handler, let's throw in some smoothing that we will do right at the very end after our for loop. So if we just put in a smooth, and let's smooth it like 5 times, and let's run that up and just see how that goes. There we go. So that is a lot smoother now. So what we're going to be doing, as I say, is we're going to be turning these path edges, these edges as hills, into the actual paths, and then everywhere that is flat is going to be where different features in. So the low areas are going to be our water, and then our high areas are going to be our cliff. But we'll worry about that when we get to it. So we have finished the hills part of the terrain manipulation. Our next stage is to go for our categorization. So here we're going to need to figure out what terrain is going to make up our paths, and then use the other heights to determine our other remaining features. So let's create a new handler, which is going to represent our sort of working out of features. We'll call this determine features handler. And if we go to our generate map, let's add that in. So determine features. So the general idea here is we're going to go through all of the terrain tiles on the map, and we're going to, as I say, determine what they should be part of. So there is a thing for that. If we go to our world and scroll to the top, we have these 4 versions. So there's 4 terrain forest tiles, which is every tile that a forest tree would be placed at. Terrain tile, which is every tile on the map, and then there's also a vertex one, which is used for heights. In our case, we are interested in doing the terrain tiles, and we're going to be working on the whole map. So let's do our terrain tile start. Oops, let's just make sure we've got our events handler in, because it's not a normal trigger, it is a handler. So let's make sure we declare that, and it is called determine features. Okay. So yeah, we've got our sort of loop through. Let's just call this V, because it will make doing some of the stuff later on a lot easier if we don't have to type so much with the variables. So we want to, first thing we want to do is determine if a bit of terrain is going to be part of a path. For that, we can use a steepness conditional. So let's have a look at doing that. Probably going to be, was it if world, and we're going to be wanting it if world location is steepness, and we're going to need the free text version in order to put a custom location in. We called our variable v. The locations in x, y, and z. We've got a vector, so we need to actually get the components out to put in each of them. This is why it's nice to have a short variable for this, so that it's less to type. I'll copy that, so in case we need it again later. We want to say that if it is steeper than a certain amount, that we're going to want it to become a path. So let's go for just a small steepness here, and just say 0.5. Next, we're going to want to actually paint our paths with the terrain that we're actually interested in. So let's have a look at that. So we're going to say set terrain. And we're going to use the set terrain at location free text. This is what is used to do a single tile, which is going to be very helpful for what we're doing. Let's have a look at the terrains that we have. Let's go for Greek grass 2. So it's Greek grass 2. Let's put that in Greek grass 2. And then we need the location, which we got our thing we conveniently copied from earlier. Saves us a bit of time. So let's just end that, and we can test out the loop. So we can do for end. Oh, that ends the for world bit. Oh, sorry, that's the conditional. Sorry, we need to end the conditional first, not the world one. If and because you have to end them in the opposite order to where you started them, and we're going to need to end the event handler. So let's just sort that out. Oops. Event handler. I'm always doing that. Should be just the handler end. There we go. So we've got our handler, which does our features. We're going to loop for all the tiles. We're going to check if it's steep enough, and if it is steep enough, we're going to turn it into the grass. We're going to end. We're going to end our little loop, and we're going to end a handler. Let's give this a go and see if this works. There we go. We have got some grass appearing. Not easy to see what is going on at the moment, as it looks like it's all forest, but we do have our grass appearing there. And you can see on the map we have. Looks a bit odd though, which suggests I've done something slightly wrong, so I'll just quickly double check. Yeah, my pause is because it didn't quite look visually what I expected, so let's just check I haven't done something a little bit silly. I suspect I've used the wrong, yeah, I've used the forest tile handler instead of the well, the forest on paints in a checkerboard pattern, which is probably why visually it looked a little strange. So let's correct that. For terrain tile, it should be for terrain tile start, not the forest one. And let's just give that another run. Ooh, I didn't actually type. I thought I was typing. And I pressed. That's probably going to break. Yeah, because I had the text box selected and I pressed the key, but it didn't type, and I didn't notice until it's too late. Let's just quickly sort that out. Change that to. Oops. It's in the filter. Crikey, I'm not having much luck here. There we go. Get that in. So hopefully now we've sorted that out. Yeah, that's more like it. I must admit I was confused before. And you can see on the map, minimap clearly now, we're starting to get our paths. And as I say, this edge bit don't worry about. There you go. It is gone. Back to normal. So, now that we have got our paths, let's get the rest of the categorization sorted out. If we go back into our triggers, we check if the steepness is of a certain amount. We do some categorization. We want to categorize the remaining terrain based on their height. The forest is already done how we want. That's why we painted the forest at the start. But the terrain is higher than a certain value and below a certain value we want to recategorize into the other types of forms. And we want this to occur when this condition is not true. So we can use the else and move that up. And then inside this else, we can do our remaining checks. So we can do a terrain height check. Location is height. We need the free text version. Let's just move that up. And let's just grab our stuff again. So we want the location. Now, we said that the land is at -20, and then the other hills are going to be -15 and -25. So for our categorization, let's say that if it is greater than, and we'll say -20, -19, so slightly above the normal terrain. Then we're going to want to categorize that as our hills. So if it's greater than the -19, then we want to paint terrain. Oops, we've already got think of that. We've got set terrain at location. Let's use that again. Let's use a cliff type. So let's use Greek cliff 1. Looks good. So Greek cliff 1. And we want to end our check. And then we want a second check. We could put another else, but there's no point. These checks are never going to conflict because they're going to be two separate things. So we're going to do another check. We're going to check that the height is less than, and we'll say -21. And that is going to be where our water is going to come in. So we're going to duplicate that. We'll move this up. And here we're going to want something that's quite nice underwater. So let's Greek shore 1 probably will be relatively okay. We'll use that for now. One thing that's nice, of course, is that if you're following this through, you can always choose your own terrain. Oops, what was it called again? Oh yeah, Greek shore 1. Greek shore 1. Greek shore 1 at our location, and then we need to end our inner one. So let's just quickly check. So we go for every terrain, we check if it's steep enough. If it is, we do our paths. Else, we then do our alternate categorization. So this one we'll categorize as cliff. And then we got another check to see if it should be categorized as water. And we set that to be shore. And then we're going to end triggers. Let's just see if that works. Okay, that looks pretty good. So you can see we've got some large areas of forest. We've got a couple of areas where they're going to be representing pools of water. And we've got our cliff areas as well on top. Now, one thing we need to deal with is the fact we've got the categorization, but our land heights are all over the place. In terms of our paths are not flat. We want the paths to be flat, we want the water to be lower, and then we want our cliffs to be higher. So the next step is going to be to turn our categorizations into proper terrain heights that are sensible for what we're going to want to do. And so we're going to effectively want to do a series of set height for terrain types, but we want to do them in the correct order. So let's have a look at sorting that out. Now, because we're going to do several terrain heights and we're going to want to run them one after another, it's probably going to make sense for us to write an event handler that will do the setting height for terrain for us, since there isn't a direct built-in trigger for that. But we can make one quite easily. So let's call this set height for terrain. And then handler. So this is going to be effectively a utility method that we're going to call multiple times. So let's define what it needs to do. So first of all, we need to say that it is a handler. So let's do handler start. And it's going to be set height for terrain. And then we'll have some parameters, name parameters. The parameter we're going to pass in what the terrain is going to be and the height that we're going to want to set it to. So let's grab those parameters out. So we can do parameters dot and then we want to go get string declared, and that's going to be terrain. And then we're going to want a second one. We want to get the int, and we want to also a float. We're going to get that declared, and that's also going to be the first parameter. Let's call that height. Now we need to go through our terrain, and we're going to want to adjust the height based on if the terrain is matching what we want. So let's put the loop in that we have already done. So for terrain tile start, again we'll just call this V, and what we want to do is we want to check if it is the correct terrain, and if it is, then we're going to want to set the height for the land in that terrain. So let's use our if world. We can use location is height. We want the free text version because we're going to use a custom location in there, and then we're going to do our v.x, v.y, v.z. Okay. Actually, what we're talking about, we're not doing height, we're doing terrain type. I'm talking nonsense. I want to check if it's a certain terrain and then set the height, not check if it's a certain height. So it's actually terrain is type. And here we want to check if the terrain is ours. We call that variable terrain, so let's grab that out. Terrain is a string, so we need to actually break out of the string. So we'll do that and do terrain. So we're going to check if it is that terrain, and if so, we then want to change the height. So let's sort that out. Terrain, terrain. Set height at location square. Now, the reason why we're using the square version is that we want the vertices on all four corners of our terrain tile to be affected. So we're going to say that if a terrain tile is a certain type, then all four vertices will be changed. This is why the ordering of doing this matters, because when you've got two terrains meeting, then both of them are going to be affected. If you set the height for one of the terrains and then set a height for the other one, the second one is going to win out if two join. That's where the ordering matters. In the case of this map, the paths are going to be what we want taking priority. So that's what we're going to end up using last. But let's sort out this location square. So we want this to become the height that we've set. So we'll put height in there. We don't want it relative, and we also need to be using the free text version. Oops. So we've got a not relative height, and yeah, we want our location in there. We're going to end our if end. And then we need to end our for loop. So for end, and then we're going to want to end our handler end. Okay, let's just check that the map is happy. It won't do anything yet, but we'll just check we haven't made it. We haven't got any compilation errors from making a mistake in our code so far. Cool, no errors popped up, so we're good to go. So let's create a new handler. And here we're going to, I don't know, let's call this set feature heights handler. Make sure it's run immediately, and let's create our handler. Let's just put that in before we forget. So it's going to be set feature heights. Okay. So event, and let's just do handler start. And as I say, we call that set feature heights with parameters, which we're not going to use here. So we want to determine the order that the features are going to be set. Now, as I mentioned, we want the paths to be done last, but the other features shouldn't be a problem. So we're going to creating a parameters and then calling our set height for terrain handler with our parameters. In order so we're not messing around with loads of variable names, let's take advantage of using scopes to so that we can just copy the code without worrying about breaking things. So we'll do scope start, and then we'll do parameters create with parameters. We want to, in fact, let's create with our terrain type, save as a line of code. Create with string, and then we can put our terrain name in there. So our first one we can do is Greek cliff 1. We're going to then want to add our height that we want to set it to. So for the cliff, we want to set it to the height, a precise height of 15. Sorry, minus 15. As that sort of fits what we were doing with the thing earlier. But if you remember, we did the initial heights and then we smoothed, so those heights aren't necessarily accurate. We're going to set those back. The heights may look a bit extreme, but we can sort that afterwards. So now we want to fire our event, so we can do events fire with parameters, and our thing was called set height for terrain, and then we're going to pass over our parameters that we did, and we will need to end our scope, and then we can end our handler end. In fact, let's just, so we can see it, let's just put an extreme value in. Let's put like 50 instead of minus 15, and then we will see obviously that it's doing something when we fire. Even better if we can spell correctly here. So set height for terrain. Let's give that a go and just see. Parameters was already defined. And yes, indeed it was, because it was defined in our handler and we declared it again. So let's sort that out. I got too lazy using the parameters twice because we had it here and it's not used. I'll just put not used. And now it should work. Just a clash on the names. There we go, and you can see now that our cliff gets set to silly heights. So we can see that that's all working good. So let's do the remaining ones, and obviously make it slightly less extreme on the cliff side. So if we go back to here, and we said that it was 15, let's do that back to minus 15. So as mentioned before with the scoping, this allows you to reuse variable names inside. So let's do copy, copy, copy. We'll push that to the end. So our second height set that we want to do is our shore. I think it was just Greek shore 1, and here we said that we want it to be -25. It's probably going to be a bit deep for the water for now, but we can correct that later on. These values don't actually have to match the ones we did earlier. I'm just doing it for now. And yeah, we'll fire for that. So that will sort out the water, the forest, and the paths. The forest should be okay, but because we want it to be the default height, but we'll set it anyway, just to be safe. In fact, we can add it slightly different, just so we can see it. So let's just copy that, push that to the end. So our forest terrain, I can't remember what it was called. I think it was, let's just have a look. It was under the hills handler. We set the initial terrain, didn't we? Greek forest grass. Okay, so let's set that to Greek forest grass. Forest grass. And here we're going to just set it back to -20. Actually, as I said, we can make it slightly different to the normal paths. We can have it on a slight hill just to add a little bit of interest to the map a little bit. So let's say -18. Might be a little bit on the steep side, but we'll see. And then finally, once we've painted these different ones, if you remember me mentioning that if you've got two terrains that meet, it will, the one that was last changed height will win. So that means any terrain that's touching the path itself is going to get affected, which is not really what we want. We want the path to win. So what we can do is set the path to the same height that it was initially, and this should then make the path overrule the other features that are nearby. So let's do that. So and push that one to the end. So here, I think it was just Greek grass too. And here we want that to set that to -20. And then, yeah, we've got our firing of parameters. Let's give that a go and see if what I'm doing is right. Hopefully not made any errors. Okay, this is starting to look a little more promising. Yeah, the forest does look a little bit steep. But you can see now that we've got our nicely formed paths with our cliffs, and yeah, sort out the cliff map edge a little bit. But yeah, you can see that we've got our heights and our makeup for the paths. You can see that we've got paths all sorted, but it does look a little bit sharp again. So let's throw in a bit of smoothing to round it off. I might drop the height of the forest down just a little bit as well, because I think it's just a little too pronounced. So let's have a look. So Greek forest grass, let's just drop that to -19 instead of -18. The cliffs, I thought, actually, or for anything, looked a little bit shallow. So let's just make them just, oops, that's not the cliff, it's the other one. No, that one first one, yeah, -15, here we go. Let's say -12, just to make them even steeper a little bit. And yeah, let's put some smoothing in there. I just go with the handler. Smooth. Let's say we can smooth it out a little bit. We could even do the smoothing before the path, so the path itself isn't affected by the smoothing, but the rest of the features are. That might be the way to go. So the path, so everything's smooth, and the path at the end is just leveled out a little bit, nice and flat. So if you push the smoothing there, smooth, and we'll smooth. Ooh, let's try 4 times. Actually, it might be too much. 3 times. So hopefully this will now make something a little bit more realistic. Okay, that's looking good. Forest looks a little bit better now. So our next step is, now we want to make it so the water actually appears where the water should go, because at the moment it is not even showing up. We disable the water, if you recall, so we need to get that water back. And also the land is all going to be at the wrong height, so we will need to resolve that as well. So the first thing we can do is we can restore our water. This is going to give us an idea of where we're going to need to raise the land to meet. So we call this a water handler, so let's just put water there, and hopefully, if we haven't messed up, this should not make any difference except put water there for the land. So we should see the same land, but now with the water there. And there we go, you can sort of see our land is under the water. This is why we got rid of the water, because you can't see what's going on very easily with the water being there. But we need to now work on the raising of the land. So let's go ahead and do that. If we create ourselves a new handler, and that's going to, let's call this raise. We're just going to raise the land. Yeah, I guess we are just going to be raising the land. That's a bit much. Yeah, let's just call it raise handler for now. This may take a little bit of trial and error to get the right value for our land, but let's give this a run. So, so we're going to need a new one. Duplicate. Let's call this raise. So in our raise, we're going to need a handler start. And we're going to be handling, oops. The event is handling, we're going to call it raise. And as I say, we're going to raise up the whole land so that the water and the terrain actually makes more sense. Let's call this set. And we're going to raise up our height, so we want to use our set height. We are definitely going to want the relative mode on this time. If we don't have relative on, we're going to lose the relative heights that we have. What we've got to do is raise the height relative to the water height. I think the water appears at 3, and currently our land is set to be -20 to be the normal land. We want that to be slightly above the water. So let's say we wanted to achieve a height of 4, so we're going to have to raise by the difference. So in this case, I think if we raise by 24, we should get what we want. And handler end. Let's give that a little go. And now you can see that we have our water, as well as our sort of cliff and forest terrain. So we are definitely getting there. One thing that's puzzling me is it doesn't appear as smooth as I thought it was going to be. Maybe because of the fact we've done the height at the end. Yeah, we definitely did the smooth. And we saw it working earlier, so it's probably just the cliff being so steep. I will just shove it to the end just to see what that does. Maybe the moving of the path at the end removes a lot of the perceived smoothness. I thought it would just make it sharp at the paths and smooth everywhere else, but let's just move it. Okay, that actually does look a lot better. So let's keep it with that rather than what I did before. Now everything looks actually a lot smoother in there. Okay, so next step is we're going to have to think about putting objects there. And we want to have the obstructions updated to what the terrain currently is set at. I guess we'll do it as part of the raise. It's not the best place to do it, but we'll add the obstruction thing. Think of like the raise being like the part where we want the terrain to actually act as the terrain. So let's do update obstructions. Now we're going to want to have our forest. So let's go and sort that out. So let's insert a new handler and let's call this forest handler. And sort of run immediately. Let's go to our generate and let's call this forest. And if we go to our forest, let's go and insert a new event, handler start. Our event is forest. So with forest, when you create forest, if we have a look, let's just forget about underbush at the moment. Let's do oak forest to make it a little bit clearer. Oh, I meant to do that. And if we select, you'll see that it places the trees in a checkerboard pattern, which I can show you with the terrain grid. One of my sort of effects deals with it. For loops does the checkerboard placing, which is what we're going to make use of when doing this forest placement. Let's just get rid of the terrain grid. Let's have a look at that. So we go to the world for, and then we got our forest tile. And again, we want to do the whole map, so we're going to do the that's terrain tile, forest tile start. That's the one we want. And as usual, we'll use our v for our variable name, and we want it to create forest if the terrain there is a tree, unsurprisingly. And with that, we had the hills handler that was setting the initial terrain. It was a Greek forest grass is what we are interested in. So let's check that it is that. If world location is terrain type with the free text version. Okay, v.x. Ooh, it's not typing. v.x, v.y, and v.z. And Greek forest grass we're interested in it being. And if it is, we're going to want to create a tree. And let's do a random rotation on the trees to make them look a little bit more natural. So if we do random float, we can declare a random float. Let's just call that heading. And we can randomize between 0 and 360. And then we want to create a tree. We'll use the forced version. The reason for using the forced is the game doesn't have to process trying to place the tree and worrying about collisions. Forced will make it guaranteed to appear. Oops. So we'll use the unit create forced. We'll use the free text one, player 0, and I think it's just tree oak, but I might have to check on that. And we'll grab our location. And we want our heading, so let's just put our heading in. We'll do if and world, for end, and we'll do handler end. And now hopefully we have a forest. We go through the terrains, we check it's a forest, we randomize a rotation, we place a tree down, and then we end our stuff. I did put the forest in, yeah. Okay, let's give that a go and see if we have got our forest. There we go. We have a nice natural looking forest in our terrain map. As you can see, we've got a nice looking map coming along. Let's cover a last couple of little things that we can do with the terrain creation. One of them might be, you might be interested in, like, how could we possibly do some eye candy and maybe some variants on the terrain, because we've done all this work creating these layouts, but having just solid terrain sometimes can look a little bit boring. But don't worry, we can mix things up even without interfering with what we've already done. So let's create a new handler and let's call it beautify terrain handler. And in our generate map, let's add the beautify in. We'll be fine doing it afterwards. I know we did the obstruction update, but the beautify is not going to change the obstruction. We're just going to change some visuals between terrains that look relatively nice, similar. So let's show off an example of how you might do the beautifying of the terrain. One way we can do that is for terrains, we can do some replacements of terrain and replace one terrain with another. This will mean we can do things like circles, but without the risk of interfering with existing terrain, and only hit certain ones. So I'll show you an example of what I mean by that. Let's declare our handler. So handler start, and in there let's declare what the beautifying terrains are going to be. If you wanted to do lots of beautifying terrains, you'll probably turn this into like a generic handler that will accept what the terrains are that it will beautify with and all that lot, but we won't do that. We'll just do one simple example here. So we're going to create ourselves a parameters. Let's call this terrain choices. And then we can do non-empty strings, and here with our terrain choices we can put the terrains that we are interested in it potentially becoming. So we started with it being the Greek grass 2, but we could also change it to some of the other ones, so like Greek grass 1, for example, and Greek grass dirt 1, Greek grass dirt 2, and stuff like that. So let's do Greek grass 1, Greek grass dirt 1, Greek grass dirt 2. Don't want to do any more of them. How's that? That's probably enough. Oh, we could do 3 as well. Greek grass dirt 3. Okay, so we got our little choices. For the sake of a little bit of variety and discussion earlier, let's use the count this time so that you can just add or remove terrains without having to update this counter, which would be quite nice. So let's just grab the number of string variables so we can get the count of that. So let's say call terrain count. Oops, that's the variable name we want that to be, not the parameter's name. That one is terrain choices. Okay, so we're going to want our for loop. So what the for loop is going to do is pick random locations on the map where we're going to apply this beautifying. For the beautifying, we're going to check if it is the initial terrain and then choose one of those new terrains at random and paint a little bit of it. So let's do that. There's probably loads of other ways of doing beautifying. This is just one example of a way you could do it. So let's do a for loop. We'll do 100 again. And so we're going to want to do a replace. Now I actually have a function to do that relatively easily already, so we can make use of that. But first of all, we need to determine what to replace with. So we need to pick one of those at random. So let's insert that in. So random. We're going to do a declare a random int. And it's going to be terrain index. Our lowest value is 0, and then our highest value is going to be our count. But things are indexed from 0, so you need to subtract 1 from the count if you're going to do it this way. That will store in our terrain index. We then need to grab what the terrain is. So we'll need to declare a new string. Get the parameter out, sorry. Parameters.get string declared. And out of that, it is out of terrain choices. So let's grab that. The index is going to be the choice that we made, which is going to be terrain index. We'll just call that terrain. Let's call that replacement. And now we can do our replacement terrain. So we can do terrain replace. Replace. We want to do a replace circle free text. And then we put the terrain that it's from. So the terrain it was going from is our Greek grass 2. And the terrain we're going to is what we have declared as our replacement. We need the location. We haven't sorted out a location yet, so let's do our location. So random float. Pos x 0 and 200. Pos z. Okay, so then we can do pos x, pos z, and radius. Let's do a random radius this time, unlike the first function. So we'll do random radius of, say, from 3 to 20 radius. Okay, so let's put our radius in. We're going to need to end our for loop. So for end, we're going to want to end our handler. So start, recreate our choices. We put our choices in. We set the count, terrain choices equal to the count on there. We do a loop through. We pick a random terrain index. We're picking some locations at random and a radius. We get that terrain out. Let's move that up to make it clearer. So it's with the choices. So we choose an index, we get it out. We then do a replacement here, and then we end. That's the wrong kind of end. It needs to be the for loop one, not the world one. And then we do event handler end. Let's see if that works. Oops, just check we've got that in. Yeah, beautify terrain. Let's see if we get somewhere with that. Okay, I don't see any change on the map, which suggests I did something wrong. I'll have a quick look and then see if I know what the problem is. If I can't figure it out, I'll move on, because it's not really the important bit on this. So just quickly go through. So we call it beautify terrain. We just check it is run immediately. We haven't declared the event name. It should be beautify terrain. That'll be why it didn't fire. So let's just run it again and see if we have a bit more luck this time. Okay, that looks somewhat better, except I am a little puzzled that it is doing forest terrain, but otherwise it does seem to be doing something. Let's have a check. Greek grass 2 looks good. This needs to be quotes, and with forest appearing everywhere, that might be just my system underlying freaking out. So underneath the underlying code, there's some missing functionality natively of converting between names and terrain indexes. I do some strange stuff to make that work, where I actually paint at the bottom corner of the map and remove it again, but you don't see that, in order to try and obtain what the names are. If you get the names wrong, then the painting can fail, and then the system gets confused as to what you have got. So for example, here it tries to convert the terrain name into the underlying indexes. It will paint what it thinks was replacement here. That doesn't exist. It will then read off what that is, and it will, if it was forest, it would have read forest, and then you saw the forest appearing everywhere. That is probably what happened. Hopefully now that I've corrected that, that should fix itself. Yeah, there we go. So now you can see that our paths have got a little bit of a mix of other terrain types as well as the normal path, just to vary things up. So finally, let's have a look at throwing down a little bit of eye candy onto the map to finish it off. One of the techniques you can do is you can use the terrain types to determine where is suitable for objects to place, and you can vary things up. And there are kind of two things you can do here. You can play into the beautifying and have it where you can place terrain based on like what it beautifies to, and you can also have stuff placed before the beautifying occurs where everything is in more distinct sort of areas. So for example, all the paths was the same terrain, so if you wanted to place an object that is only on paths, then you'd want that to run before your beautifying occurs. For simplicity, let's just go for before beautifying occurs, so we can reliably see our objects appearing as a technique. Let's insert a new handler. Let's call this eyecany handler. And as mentioned, we're going to want this to run before the beautifying, so let's call this eyecany. Okay, let's put our handler in. Handler start. And we want to call this eyecany. So a basic idea here is we can go through the tiles of the path, and then we can determine if a tile should qualify for an object to be placed, and if so, we can place an object there. Obviously we don't want every single tile on the map to contain such an object, so we want it to be more of a probability based system rather than just throwing it on everything in order to avoid some potential issues. But we've got plenty of ways we can do that, so let's make a use of some of that. So let's do a straightforward example of that. And in fact, why don't we make it into a function to make things just a little bit nicer for the placing of the objects, so we can do multiple objects without having to copy everything multiple times in the same kind of way. So let's do, as a small tangent, let's do a new trigger, and let's call this paint objects handler, which may sound a little strange. It's going to be more like a conditional painting, but hopefully it makes sense in a moment. So paint objects, and what we're going to want is, let's grab our parameters and let's do parameters dot get string declared, and we'll call that unit, and we can get ourselves a float. And for that, we will use that as the probability that an object will be created at that location. Probability. Okay. Let's put ourselves a loop. World. We want to do a every terrain tile start. We'll do V as normal. So we've got a handler, we've got our stuff, we've got our every patient. We now need to check if the terrain is the path. We can do that. We need that if world terrain is location is terrain type. Free text v.x, v.y, v.z, and it's going to be Greek grass 2. So if it is of an object, Then we want to determine if we want to place the object, so we need to do a random roll. In fact, I think I've even got a function to make that a little easier. Let's just see. If not, I can do it this way. There we go, if random chance. So here we can put our probability in. And so if it qualifies, then we can do our unit create. Interesting, we can do a forced version or a not forced. If we do forced, then it means obstructions will be ignored. But there is a disadvantage of doing this, which is if you use the forced version, you could have a situation where two objects get placed in exactly the same place. If you do not forced, then that won't happen unless the objects are allowed to stack on top of each other. However, you will potentially run into performance issues if you've got large objects being placed. So it can be up to the situation as to which one is better. Let's go for the not forced version, as we just go for some simple objects and we don't really want them placing on top of each other. So let's just do unit create, just the standard one. Create unit create, and we need the free text version. Apply a 0. Proto name is a string, so we need to put our thing in. We'll do units. We've got our location, which is this one here. Oh, we need to do a heading. Again, we can just do a random variable for that. So we'll just do a random float heading. Obviously, if you do some of these things a lot, you can always make an event to do some of this work for you, but we'll just do it directly here. So we'll create a random heading, and then we can put our heading in. Okay, and then we need to end that if statement, and if end is the convention, yeah, and that's also a conditional, so we can end that. Then we need to end the world one, so then we need to end the event handler one. Handler end. Okay, so we grab our unit, we grab our probability, we go through the terrain tiles. If it is the correct terrain, we roll a probability. If we succeed, we randomize a heading, create at the location with a heading, we end out of there. Oh, one of our conditionals end. I must have replaced instead of duplicate. Let's just move that up. So there we go. Then we end the world and we end the handler. Let's go back to our eyecany handler, and again we'll just do not used here so we don't get the clash we had earlier. And we'll do the scope trick again. So scope start, we'll parameters create, and in there we'll again we can create with the string already in, so let's do that. Create with string, so we need an object. Let's do columns, and we need to put a probability that it will happen. So let's add a int in there, and as I said, that's going to be our probability. Oops, not an int, we want it to be a float. 0.02. So I think that's actually we'll do 0.01. So every 100 tiles of path on average there'll be a column. Let's fire our handler. Events, fire parameters. It's going to be paint objects with the parameters that we have, and we will scope the end of that. Okay, yeah, that's all good. And our generator has, we'll just check it's got it in. Yeah, beautify terrain, eyecany. Okay, let's see if we get some columns appearing. Hopefully it will work out fine. Rule is not a valid operator. Interesting. And that didn't really give a clue of where it is. That's a little bit unfortunate. If it's something like that, that usually indicates that I haven't closed brackets properly or something like that. So let's just have a quick look at what that might be. Ah yes, I didn't end the handler. So let's put that in. Okay, let's give that another go. Rules are what the triggers run with, so if it's getting confused with symbology, it's probably through that. Okay, so it didn't know what probability is. Okay, let's see what the problem there is. That's going to be in our paint objects. Let's see. I did get with a set instead of get with declared. When you use a set version, that is where you're setting to an existing value. We don't have that, so we wanted to declare it rather than get. The get is good if you got like a global variable or you got some like local one that you're using. But as I say, we need the declared version, not the set version. Hopefully now that should work. I'll give you some ideas of sometimes things go wrong, but that's just the way things are. Okay, so heading is not right. Probably might have made the exact same mistake there and accidentally used the set version instead of the declared. I guess this is what happens when you're trying to do something live for a video like this. Let's have a look. So, yep, made the exact same error again. So let's variable. So it's going to be random float. We need it to be a declare instead, and it's not to 360. Yeah, if it says something doesn't exist or doesn't know what it is, it's probably because you haven't declared it and you're just trying to call set. Okay, and here you go. You can now see that we have some columns. Let's add one more piece of eye candy just to show the system at work. We'll put some like animals or something like that. Elk? Yeah, there's elk. Okay, let's go back to our eye candy and let's do another entry. Okay, and end the handler. Change that to elk. We'll have them a little more frequently this time, and yeah, paint objects, and that should be it. Let's have a quick look. There we go. Yep, we've got a lot more elk than we do the columns, which is nice. We do still have the edge of the map thing, but as I mentioned, it's a visibility issue. You'll see that it has now disappeared. But as you can see, we have a great example of how you can generate a map with triggers. So, one last area to cover. Let's see if we can resolve the map edge issue. So let's have a quick discussion about what is going on there. There's a few things that are actually going on with this. Let's just show a bit of an example of what is going on. I'm just going to save this map so we can come back to it. So I can just go on a blank map. So let's just call this map from triggers example, which is our example we just made. And if we go and generate a new map, okay. So one issue is that as of this current build, and this may change in the future, when terrain is in the fog, i.e. not in line of sight, it does not update with changes. And when I say doesn't update with changes, what I mean is that, I'll give you a nice example of that. If I put some anti-bites down and somewhere else, and I'll just insert my map. Sorry, I need the trigger loader. Oops. Go. And I need a trigger. Let's show you an example. Let's do paint map. Because, yeah, it's worth going through this because you'll probably run into this when you're doing maps and wondering how on earth you're going to solve it. And the answer is it's a bit of a pain, but I'll show you. So let's just do an example. Let's do Norse Snow 1. And let's also change the height because it also comes up with that. Terrain set height. And we'll drop the terrain so it makes it a little bit more obvious. Actually, no, I'll raise it, actually. Let's go raise. Okay. If I playtest, you'll notice something a little bit weird happens. So we've got our terrain change, but you can see at the very edges that the terrain is as it used to be, and as you move the unit, the terrain is changing, which is a little weird. So it doesn't update until you have line of sight. It doesn't update in the fog or black map, which causes this problematic situation. And worse, as you saw earlier, if we try and go to the top area here, you'll see that things mess up. So if I scroll around, you'll see that at the very edge of the map, it doesn't even update properly. This is a bug in the game, which I have no control over and cannot write a script fix for you. There is one workaround I have found, which is a little weird, which can fix this for you, both allowing it to update in the fog and fixing the map edge issue. However, the fix is a little strange. To fix it, we need to have a line of sight change with the player who you want to have the fix applied for. And when you do this, it will fix it in the future. It won't happen immediately. You can't just run this fix and expect it to be like, do some stuff, apply the fix, and then I'll show you what I mean. If I do a change of line of sight with a player, and that line of sight change actually has an effect, it will fix the terrain. Why this fixes it, I have no idea. but it does. So I say that I now have line of sight of player 2, and I run up the map. And you'll see now that the line of sight is the terrain has now actually updated properly, and even the top edge of the map now also works correctly, which is a little strange, as you can imagine. But as I mentioned, the line of sight has to have an effect, and it needs time. So unfortunately, what you can't do, which would be ideal, is to simply just toggle visibility on and then off immediately afterwards like that. There has to be some time delay between a switch. So one trick you can do is set the visibility to something you don't want, generate your map, and then set the visibility to the correct value afterwards. So you can see now that the... not sure why the map is revealed, but you can see that the line that hasn't actually worked properly. The reveal map might actually be the random bug that occasionally happens in the game where the map is revealed for some reason when you play test. I have no idea why. I'll just run it again, just see if it fixes itself. This is a bug that seems to occur at random. Yeah, see, it's fine. But you see, the fix hasn't worked. So what you might do typically, as I say, is fade out the map or something while you generate it. Use the fade to black, generate your map, and then fade in afterwards. And then while you're generating, have the visibility change. So what I mean by that is, let's say you do your stuff, you set your visibility to player 2, you say yes, and then let's just rename it to 2 to make it clearer. And then you might say you need some time later to apply the fix. So here you might then undo having line of sight of player 2, and that'll be the point where you might see the map. As I say, maybe using a fade out or something to work around it. I'll just show you that in action. And now we don't have line of sight of player 2, but now we have the map working and visibly appearing correctly. So this is the fix that I do with my existing maps to get them to work. The difficulty is you need suitable players to change to. You can't change visibility. The visibility, as I say, change has to actually have an effect. So you can't change the visibility to something that's already the same. Just doesn't work. You might say, oh, what about using player 0? The thing with player 0 is that it gives you visibility of the whole map, as you saw when we were doing that map generation. So you can't just simply switch the visibility to nature or something like that and expect it to all work. So you have to just be a little bit clever with things. But that covers how you can fix the issue at the edge of the map. And in fact, if we go back to our example, we could put a fix in for now and say we have player 2 visible. I think that will work. Or in fact, we should in theory be able to just simply have this occur at the end. So it'd be a visibility change after the map is generated, and that might actually fix things. Let's just see. Because we're using that to reveal anyway. So let's see. Player 1 has line of sight of player 0 after doing all the map generation. Let's give that a go. Let's see if that does the magic. And it does. There we go. So we've actually used the fix and the line of sight change both to have our map revealed and apply the fix in one go, which is amazing. And we now have our map generated, all from triggers. And you can imagine this generates different maps each time. There are tons of different techniques for generating maps. This is just a particular technique that I do for generating maze-like maps, as you can see here with objects. I have made use of this technique in a few maps like Gladiator Worlds and a couple of others, like one of my escape maps I think has it in the Strange Forest one for doing this. So there are sort of nice things you can generate, but hopefully this gives you an idea of what can be done with triggers and what you can achieve, which as you can see is an entire map. So yeah, all done with the triggers. The only thing I'll round off with saying is map generation on the fly can take some time. So you may wish to, in order to avoid people freezing up, you may wish to consider throttling the operations. With us doing it using handlers, this becomes quite sort of natural. In terms of the throttling, you could, with these events, because we're saying do this, do this, do this, so what you could do is you could use the scheduler to run each of these after a delay amount of time in order to sort of do a bit at a time, and maybe have the screen in black screen or showing some message or something while the map is generating, just to keep players from, as I say, being frozen up. There's lots of ways of doing it, so it's something I'm not going to worry about in this example now, but it's something that you may want to think about, especially when generating larger maps. If you're doing small, tiny maps, you can basically do it instantly. Gladiator Worlds, for example, that map is very small. I generate it straight away. But other maps, like my Splunky map, which does dynamic generation, where the maps are a little bit bigger, so I do have like a progress system for that. But hopefully you have seen some examples of how to use my terrain generation system and generate a full whack map with forest, cliff, water and terrain. I appreciate this stuff is quite advanced, especially with doing the water, where I did everything underneath the height of the water and raised the land up at the end. But hopefully you can see that the technique works. And as I say, it is what I actually do for generating all of my maps. I've given you some examples of some custom features of, for example, setting terrain to height using some events to simplify and then allow just the calling of it with different parameters to have them all act differently. This is how you can effectively build your make your building blocks. You can, as I said, I did an example with replacing terrain at steepness, but you might have other examples. So an example I've done in the past on some maps is I've replaced terrain that is higher than a certain amount. So an example being is if you had some mountains and you wanted to put snow on the very top of them, then you might have a function that goes through all the terrain tiles and looks to see if the height is above a certain amount, and if so, then to replace the terrain with a different terrain. And then you might do a similar thing and maybe do a height check or terrain check and paint snowy trees instead of the normal trees. There is so much opportunities and out there in terms of what you can do, and your imagination is your limit, is what I would say. Hopefully you found this useful. I appreciate this was quite long, but I hopefully gone through how you might create a map on the fly with triggers in detail with a nice worked through example. Enjoy and I hope to see some amazing maps from you, and otherwise hang around and I'll hopefully bring out a new trigger tutorial soon, covering some of the other remaining areas that I've added to my trigger pack. Until then, good luck with your map making and see you all next time.